Oh no, it's okay. You have picked the wrong answer. The correct answer for the electron pair geometry of CH4 is tetrahedral. Let me help you out. Let's discuss on how to get the answer. So first, we have to calculate the total valence electron. Carbon atom has 4 valence electrons, while hydrogen atom has 4 valence electrons. So the total of valence electron is 8 valence electrons. So next, we have to draw the Lewis structure and then find out the number of electron pairs. So we have 4 bonding pairs. Using the Vesper theory, we can find out the electron pair geometry, which is tetrahedral.
Now let's talk about the basic molecular geometry. Basic molecular geometry occurs when lone pair is not present in the central atom. For example, when the electron pairs of the atom consists of all bonding pairs, means the molecular geometry of the atom is in form of basic shape. So there are 5 basic molecular geometry, which is linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, and octahedral. Linear is for 2 bonding pairs, and trigonal, planar is 3 bonding pairs, tetrahedral is for 4 bonding pairs, and trigonal bipyramidal is for 5, and octahedral is for 6 bonding pair electrons. So you can see the shape in this diagram. However, not all central atoms consist of only bonding pairs. There are central atoms that consist of lone pairs too. When the central atom contains lone pair and bonding pairs, the lone pairs will influence or compress the bond angle, although it do not account for the shape. A lone pair exerts greater repulsion than a bonding pair because lone pair experiences less nuclear attraction, and its electron cloud is spread out more in space than that for a bonding pair. So now let's take a look at this table. This table is the molecular shape of the atom according to the number of electron pairs. So as mentioned before, when the number of lone pairs is 0, the shape is equal to basic shape. And there are 5 basic shapes, which is linear, trigonal, planar, tetrahedral, and trigonal bipyramidal, and octahedral. So each shape has its specific angle. So when a lone pair is present, the lone pair will compress the bond angle, so causing the bond angle to be smaller than the basic shape. For example, when the number of electron pairs is 3 and there's 1 lone pair present, the shape will become bent and the angle will be less than 120 degrees. So for conclusion, if you want to predict and draw the molecular geometry shape of a molecule, the first thing we need to do is draw a plausible Lewis structure. And then we need to count the number of electron pairs. Beware that double bond and triple bond is counted as 1 pair because there are presence of pi bond and sigma bond. And then the third one is to establish the electron pair geometry around the central atom. And then last but not least, we need to use Vesper theory to predict the molecular geometry.
Now let's try another question. Guess the molecular geometry of H2S.